Hey guys, welcome to another lecture from Introductory Statistics. We have been working on the concept of PDF and CDF. And in the previous class, we did it in detail what a CDF of a discrete random variable would look like. I would like to take up a specific case today, the case of geometric random variable. So I'm going to start it with a question. If you remember, while constructing PDF, I have discussed this question. We constructed the PDF for this particular case. Starting at a fixed time, we observe the gender of each newborn child at a certain hospital until a boy, capital B for boy, is born. And let lowercase p be probability that boy is born. Okay. The PMF of the random variable x, which we are taking as the number of births, had the form, if you remember, so it will be 1 minus p to the power x minus 1 into p, okay? Like girl, 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 then boy, okay? And x can take value 1, 2, 3. So px is equal to 1 minus p, x minus 1 number of times, so to the power x minus 1 into P and 0 otherwise. Okay. Let's calculate what will be CDF for this random variable. This x will be value of the random variable x. Capital Fx is equal to summation Py, where y is less than or equal to x. That is, you'll add up all the probabilities. Probability x, the value of x starts with 1. So probability at 1, probability at 2, so on and so forth, till x, including probability of x. Okay. So this means it is nothing but summation 1 minus p to the power y minus 1 into p, where y is less than or equal to x. Then again, the moment you will start giving values 1, 2, 3, 4 to the variable, you will get the same thing, this sum. In other words, this means it is summation 1 minus p to the power y minus 1 into p, where y takes the value 1 to x. Y can take value at the maximum x, okay? And now if what you can see here is that p is just a constant here, it doesn't have the variable in it. So this is equal to, I can take p outside. This is summation 1 minus p to the power y minus 1, where y goes from 1 to, let's play with this summation. So p is outside, okay? Now what you can do is take this 1 here, and this summation becomes y minus 1 equals to 0 to x. 1 minus p to the power y minus 1. So instead of y minus 1, I can take it as, say, I can take this entire sum as y goes from 0 to, I can also do another thing, no? I can say y goes from 0 to x minus 1, and the index here, since I've taken y minus 1 as y, so instead of y minus 1, you will write y here. See that this sum and this sum, it's basically the same thing. You can also take it as some other variable. You can put it as, say, a, you can put it as, say, z. So basically what we are saying that some z is going from 0 to x minus 1, and the summation is 1 minus p to the power z. Then इंडेक्स में वेरिएबल क्या है उससे फर्क नहीं पड़ता, सम कहां से कहां तक जा रहा है वो सही होना चाहिए. ओके, so you can write it either in terms of y, you can write it in terms of z. आपको जैसे भी लिखना है आप लिख सकते हो, ओके, उससे फर्क नहीं पड़ता. लेकिन yes, this is what it is. You can write it down like this. So after looking at this form, you should be clear in your mind कि ये सम तो ज्योमेट्रिक की तरह दिख रहा है. Can you see? It's a, you have something in power. So ये बिल्कुल ज्योमेट्रिक की तरह है ना सम. Okay. So you will have to recall geometric series, ज्योमेट्रिक सीरीज में सम क्या होता है, फाइनाइट सम क्या होता है? सो वी नो दैट समेशन a to the power r, where r goes from 0 to say k, is equal to 1 minus. Now how many terms are there? Since r is going from 0 to k, that means in total k plus 1 terms are there. So 1 minus a to the power k plus 1 upon 1 minus a. That's what you get. That's the reason why the variable, whether you take y here or z here, it will not matter, because ultimately that means ये जो हमारा सम है इसमें क्या था हमारे पास, p summation y is equal to 0 to x minus 1 minus p to the power y. This sum is p multiplied by, this sum turns into 1 minus, your a is 1 minus p to the power k plus 1, that will be x minus 1 plus 1 upon 1 minus p. So this will be p multiplied by 1 minus p to the power x, whole thing upon 1 minus 1 cancels and you are left with p. P and p cancels. Basically what you get is 1 minus p to the power x. What have we just calculated? We have calculated capital Fx, the CDF, for any fixed value x of this random variable x, which is basically a geometric random variable. Geometric random variable because when you are calculating probabilities here, it is a geometric sum ultimately. So this random variable is also called geometric random variable. If you understood my previous video, you would understand how to then write down it as a function. You can write it down that capital Fx in this case is 0 when x is less than 1, because the random variable is taking values 1, 2, 3, 4, so on and so forth, starts with 1. Since CDF will be a constant between two positive integers, it will be just a constant. It will not change. It changes only when a new integer value comes in from the domain. Okay. So that is why when x is greater than or equal to 1. Now, since I'm not writing 1, 2, 3, 4, I'm giving you an interval 1 to infinity. Here it will be capital Fx will be 1 minus p to the power greatest integer x, where greatest integer function, if you all can recall, greatest integer x means greatest integer less than or equal to x. So, मान लीजिए, here we are talking about 2.7. Suppose x is 2.7. The greatest integer x will be 2. And hence, if you will try to figure out what is the CDF, it will be 1 minus p to the power 2. So till now, what we have done is we have calculated fx using your PMF. We have calculated CDF using the probability mass function. So, we know that, okay, if I'm talking about capital Fx, it is probability of 1 plus probability of 2, considering this question that we had, till probability of x. You will add up all these probabilities, right? But there is a reverse relation as well. So there is a way with which we can go to PDF from CDF. How will this happen? Let's see. अब इसका हम use कब करेंगे? When will you actually use it? If you are given CDF, that is capital Fx, from there you can find lowercase fx or px, whatever you call your PMF. कैसे भला? Suppose I want to know what is the probability when x is taking value 3. So that is P3 or P probability x is equal to 3. ठीक है? अब I don't have the PMF. Suppose I don't have the PMF, but I do have CDF. So मुझे पता है that I'm given a formula with which I can figure out what is the probability till 3. Okay. So what I can do here is I can say, okay, I have the probability till 3. So what I can do is I can just add P0, P1, P2, P3 is what I have here. I'm adding these, and let's now subtract. What I'm adding, I should be subtracting also. If in case say x is taking values 1, 0, 1, 2, 3, I'm not taking a specific example. In any example, say x is taking value 0, 1, 2, 3, so on and so forth, and you are given capital Fx instead of PMF. So what do? I have to somehow use the CDF. Now, do you see what? By adding P0, P1, P2, and you already have P3 here, for which you don't have the value, but yeah, you have it here. So what are you doing here? By adding these, I have actually created CDF here. And I have to subtract also. But what I've subtracted is also a CDF. If you observe, this is nothing but probability x less than or equal to 3. And this is nothing but probability x less than or equal to 2. In other words, it is capital F3 minus capital F2. Similarly, if you have the case that you have to find out probability that x is taking the value 4, but you are not given PMF, you are given instead CDF, then what will you do? Clearly think about it. You have P4 is what you are trying to find out. What you will do? In order to get it to CDF form, you will have to add P0, P1, P2, P3. You've added these. If you're adding, you have to subtract also, right? So you have to subtract. In this process, what have you actually done? This portion that you have created, this becomes CDF for the value 4. That is capital F4. And this value becomes capital F3. So you can see it for yourself in discrete random variables. If I want to find out probability x is equal to A, that is the probability mass function at A. This is nothing but capital F at A minus capital F at A minus 1, where A is taking some value, A is some integer. Okay, this will always happen. And this is a generalization that you can keep in your mind whenever you're given a CDF. How do you find out point probability, or how do you find out PMF using CDF? This is an extremely important concept for you to actually remember, because many a times it happens that you are given certain values. For example, suppose in a question you are given, okay, capital F2 is 0.7, capital F1 is 0.5, capital F0 is 0.2. Now, suppose x is only taking values 1, 0, 1, 2 and 3, 4, so on and so forth. So from here, if they ask you, okay, what is probability x is equal to 2? You can quickly figure it out by taking capital F at 2 minus capital F at 1. So this will be 0.7 minus 0.5 is equal to 0.2. Okay, so that's how you can go from cumulative to point probability. I hope this will really help you. This is an important concept to remember. Thank you very much.